So I have, there we go. So I haven't worked with your guys' districts or schools before, but it's great to see you and thank you for being here today. The plan for today is to do a refresher of our middle school STEAM course. And I'm curious, Robin and Laura, feel free to type it in the chat or say out loud, since there's only a couple of you where you're joining from. And if you have experience already using the course, I'd love to know that too.
We haven't yet, but we're exploring maybe adding it on into our programs.
Okay,
Yeah, so we're thinking about it.
perfect. Okay.
I do not have any experience with it.
All right, welcome. And Christine, I see that you just joined too, or just jumping in with getting started. Feel free to comment off of me or jump in the chat and tell us where you're coming from and if you've got any experience so far with the middle school course. The objectives for today are threefold. We'll learn how to use the interactive lesson and lesson builder. That's a strong component of the middle school STEAM course here at Sam Labs. We'll explore content together, and we'll also talk about pairing that content with our hardware. I mentioned my name is Alyssa. I am our customer success manager for the Midwest here at Sam Labs. Before coming to Sam Labs a couple of years ago, I was a classroom teacher. I taught pre-K in Houston, Texas, and kindergarten up in Milwaukee, where I'm currently based. So on the opposite end from middle school there, but it's my role to support all of our teachers here in the Midwest as they implement Sam Labs all the way from kindergarten and on. I will make sure you guys get a copy of the recording once everything's recorded and uploaded. But if you need to reach out to somebody in the meantime, my email is down here. And you can always send me a message and I can connect you with your regional customer success manager as well. Speaking of your regional customer success manager, we have 5 different CSMs spread out all throughout the United States. I'm up there in the Midwest in yellow, but we have Joel in the Pacific Northwest in California. We've got Melinda, who covers part of California as well, and then usually what we refer to as the Southwest, but she goes a bit north too. Then we have Lauren up in the Northeast, and currently Mackenzie, our head of customer success, is supporting the Southeast region as we work to hire a fifth customer success manager. So when you get these slides, or right now, feel free to scan your CSM's contact info, and that will give you their email if you don't have it already. And customer success managers are basically the first line of support for you at Sam Labs. So if you have a question that something's not working right, or you want to know more, this is the person that you should go to. This is meant to be a refresher today. So even though you guys don't have a lot of experience, we'll kind of do a crash course on what it looks like to use the STEAM course with middle school students or any kiddos that 6 to 8 course is appropriate for. So it's not all the same info that you get in a full level 1 PD, but it should give you a good starting place. Since some of you are brand new to Sam Labs, I wanted to put up this free trial screen. If you don't have access already, I encourage you to sign up now so that you can access the platform as I go through the training today. To access a free trial, you'll just go to samlabs.com and there's a free trial button in the top right corner where you can input your information and then it will automatically set you up with a trial account. And that way you'll be able to follow along with me today and continue exploring. And that's just samlabs.com. And I'll put that in the chat too. In our middle school STEAM course, it is grade banded 6th through 8th grade. And instead of just playing this video here and walking you through the student experience, I'm going to tell you all about it. So the way that our middle school course is designed is that it's grade banded, like I mentioned, 6th through 8th, and it's focused on different careers within STEAM. So while we start students out with an introduction to how to use our hardware and software, we then move on to discussing different career fields that are a part of STEAM. Some of them are very traditional career fields that you probably think of when you think of STEM, like architecture and agricultural science and aerospace engineering. Others are more out of the box, like filmmaking and entertainment. There's an artificial intelligence unit, even a video game design unit. This course is designed to be very student-led. It's in what we call our interactive lesson structure, where kids are inputting their information and recording their thoughts as they go throughout the lesson together. That's being facilitated by the teacher. In itself, the course currently has 10 units, although we are constantly developing new content and expect us to have at least one other unit by the end of the school year. If you were doing one lesson every day at a very quick pace, there would be enough content in the whole course to fill a semester-long course. So there's about 9 or 10 lessons for each of the 10 units. Likely, you're implementing SAM Labs in conjunction with other content and other curriculum, or you'll be spending extra time on those extensions and breaking it down for your students. So it's likely that it can last longer than just a semester. I mentioned that it's grade banded, so there aren't specific lessons that are designed for 6th grade and 7th grade and 8th grade, but your customer success manager is a person who can help you decide what might be the most appropriate for 6th graders versus 7th versus 8th. The goal of the STEAM course isn't necessarily that your kids are going to leave experts at coding in Python and JavaScript, but they will be using multiple coding languages in order to explore these different career pathways. They will use 3 different coding languages actually, or 4, I guess how you look at it, as they go throughout the course. In our content, when we're looking for the middle school STEAM course, the best place is going to be to go right into SAM Studio. When you log into SAM Studio, if this is your first time logging in a while, but you've logged in before, you might notice that this looks slightly different. We completed an update last week that updated the interface a bit. If this is your first time seeing it, great, that's amazing too. To access all of the content and resources in SAM Studio, you'll go to the Content Hub over here on the left-hand side of the screen. This is the teacher-only section. Students won't be able to see your Content Hub. From here, to find the middle school STEAM course, you'll filter under Courses for 6 to 8 interactive STEAM course. Once you have that STEAM course selected, you'll then see all the lessons and units that are designed to be a part of this course. However, the best place to look for the lessons that you're going to be teaching and for lesson overviews is this first box here that says 6 to 8 STEAM Teacher Resource Pack. If you click Favorite here and click the little star, when you go back to your home screen, all of your favorites populate here at the top, so that's easily accessible for you in the future. Once we open up that 6 to 8 STEAM Teacher Resource Pack, we see a handful of resources. The first in red being your course overview summary, the second resource here being an implementation FAQ guide, and the third being a timing slide deck that can be modified and edited by you for each individual lesson. I'm going to open the course overview summary and show you what the scope and sequence for this course looks like. I mentioned that there are 10 different units currently, with about 9 or 10 lessons per unit. You'll notice that at the top, we have what unit we're looking at currently, an overview of what students will be doing in that unit, and then it breaks down the unit by lesson. We start with Unit 1, which is an introduction called Welcome to SAM Studio, where we teach students how to learn how to use the hardware and software, and some basic vocabulary that they'll need as background information to begin the course. After that first unit, we move into a unit on future-ready skills, where students has less of a coding focus and more of a focus on other soft skills that they'll need to be successful, like teamwork and collaboration, communication and voice, critical thinking. And then after those first 2 introductory units, we jump into different career pathways, starting with architecture here in Unit 3, filmmaking in Unit 4, and so on until we get to our final unit, which is a culminating unit, Unit 10, on spotlighting different STEM pioneers in different fields that students may or may not have heard of before. They wrap up the full course then by doing a spotlight on themselves as a STEM pioneer, or what they will do with these future-ready skills that they're learning in the future. It's all about exposing students to different career pathways that they may or may not have considered as STEAM careers, and learning about science and computer science, and coding through the lens of those different careers. I realize that I'm doing a lot of talking. If you have big questions as we go throughout, please interrupt me and please ask questions or type them in the chat as well, and I'd be happy to answer. We'll also have some Q&A time at the end. Something helpful about this unit overview here, this scope and sequence, is that all the lessons are linked, and it also tells you which coding platforms and blocks students will use throughout the course. The middle school STEAM course, I'm going to go out of order here for a minute. The middle school STEAM course uses 2 different SAM Labs kits. It will use a STEAM course kit, which is typically either steel or purple, depending on when you got it. Newer ones are purple. And it will use a STEAM Plus kit. In total, students will have access to the blocks listed here. Each student group will have 2 DC motors, a light sensor, an RGB LED, proximity sensor, servo motor, pressure sensor, and microbit, plus some additional accessories. The scope and sequence tells you which of those blocks that you need to prepare to give students during that lesson. It also tells you which coding platform students will be using. In this unit, kids go back and forth between using SAM Space, which is what we call flow-based code, and SAM Script, which uses a combination of block-based coding and lets students translate that into JavaScript or Python. So they're being exposed to flow-based coding, block-based coding, coding in JavaScript and in Python through the course. Like I said, they're not necessarily going to be experts in JavaScript and Python by the end of the course, but they will have exposure to it. And for students who are ready, they will be able to build expertise there. You'll also notice that all the lessons are linked and they have the main focus standard. Computer science standards are the main ones linked in the first course, but you'll notice throughout units, we have different focus standards. Here we're using ISTE standards. In the architecture unit, there are a lot of NGSS, Next Generation Science, but there are also NCIS, National Core Art Standards built in. So it's a very well-rounded STEAM course where not every single lesson will be on coding or every single lesson will be on computer science, but students will be able to integrate other subject areas as well and other areas of interest. You'll also see that not every single lesson uses coding. In this case, students are building a physical prototype. They're not using the coding platform as the main part of the lesson. They're not using blocks. They might use those things in an extension, but not every single lesson will involve coding because, like I mentioned, it's a well-rounded STEAM course, not just a coding course. Typically, there will be coding in part of the extension, though, for lessons that don't necessarily include it in the main component of the lesson. You'll also notice, it's kind of hidden here, but you'll notice that most lessons in their description start by saying in this lesson. For our middle school STEAM course, lessons are designed to take between 45 and 60 minutes, depending on time spent on the extension. Some activities, however, instead of saying in this lesson, will say in this activity. Know that activities are shorter. They're designed to be finished in about 30 minutes. So that's the differentiation between in this lesson and in this activity. Activities are shorter. They don't have a full lesson plan. Instead, they have an activity guide. When you're ready to teach one of the middle school lessons to your students, the easiest way to start that is by clicking the name of the lesson that's linked here. I'm going to click Lesson 1, Welcome to SAM Studio. When I do that, I'll be brought to the lesson pack page. As the teacher, you'll want to look at the lesson plan because there's extra information in here that unless you review this as the teacher and facilitate these discussions, students will not see as a part of their interactive lesson. So the course isn't just designed to be assigned to students and for students to be left alone and complete it. There are points where the teacher will have instructional notes and background information to share. While this is in a script, it's very useful to print out or to have on a tab on your computer so you know what points students will need this information shared with them. The lessons follow an engage, apply, reflect format. The engage is the hook, how we're getting students introduced to that lesson content or the activity. The apply is when they're applying the bulk of their learning. And then in the extension, in the reflection, students will reflect on their learning and rate themselves on how well they did that day. There's also always an optional reflection or an optional extension, almost always, where students will complete some sort of extension activity for further learning. Since this is the first lesson, there's not really an extension built in, but most other lessons do build in that extension. There's even a forward link for every lesson so that you can tell students what the purpose of this lesson is and what they'll be doing with that knowledge next, because we know that our students always want to know that why behind what they're doing. Going back to that lesson pack page in Sam Studio, you can see some lesson details up here, a description and the time frame and the course that it comes from. When you're ready to use this lesson with students, instead of just clicking view, you'll go ahead and click copy. Once you click copy, a lesson will be added to your interactive lesson library. And you can see I was brought here in this tab to my interactive lessons. Now I have that copy that I just made at the top of my screen. It's a copy of the Welcome to Sam Studio lesson. From here, I can open the lesson and then decide what to do. All of the lessons are completely editable. So you as the teacher are able to edit lessons, add in additional information, swap out videos, change up questions, and do whatever you need to differentiate this for your students. You can also edit the name. I typically will click edit so I can remove the word copy from that name. And maybe I'll make this for my 7th grade class. If I'm done editing, I can press save and close up here. You also have the ability to preview this lesson as the teacher or as a student. I'm going to go to the Engage section here. This is my teacher preview. I can see everything that the teacher will see as you go through this lesson. Anything in an orange box is not visible to students. This is here to help you lead the discussion and to help you grade student responses. And as we go throughout the lesson, I'm going to move this bar around. As we go throughout the lesson, you'll see each section, engage, apply, extend, reflect. And it will show you what students should be doing and also give you the teacher answer key. As the teacher, I suggest when you're teaching a lesson with your students to display the student preview on your smartboard or on your display screen while students open this on their screen and work through it. That way, as the teacher, you can pause the whole class to play a video or to lead a class-wide discussion or share extra information. It is important to note that when students are working in their interactive lesson, that this is currently not auto-saving. That means if your students do not finish a lesson in a day, they will need to click the save button that will show up for them in the top right corner in order to save their work. If students complete and finish an assignment in one day, they don't need to click save, they'll just click submit. But it's important to note that they have to click save. So please get them in the habit of clicking save early and often so that they don't lose their work. You'll notice that there are different types of questions inside of interactive lessons. This here is a match or a sorting activity where students are sorting what is an input and what is an output. They might also have multiple choice questions, long answer questions, matching activities. Anything that's multiple choice like this or where there's only one correct answer will auto grade. So the teacher doesn't need to spend time grading the student's work when it's only one answer. However, if students have a coding response or an extended response where they're typing an answer, the teacher will need to select a grade for that based on criteria that we provide. The great thing about the interactive lessons is that students can complete their code right inside of the interactive lesson. They don't need to open another tab and open Sam Space. They can come in here, add their blocks right to their workspace. They can even pin it to the side of the screen so they can see their prompt next to their lesson and build their code and connect their blocks right within this same platform. One newer feature that was released towards the end of last year is the ability to add notes. So students can come in here and add notes and annotate their work. When I press the button, which is an input, then a sound will play, which is the output. So you can ask your students to annotate their systems to give you more information about how they're working through that problem. And then they can unpin this from the screen as well. This also still supports changing of languages and changing of settings for your students. If you'd like to change the language of the actual interactive lesson, this does support all the languages in Google Chrome. So if you translate Google Chrome and change your settings in your browser, it will translate this platform as well. And it works with speech to text as well, too, or text to speech. If you accidentally close out that outline like I did, you can open it up by clicking back here. And we can go back to the teacher view and so on. So yeah, I suggest displaying the teacher view when your students are working through the interactive lesson, but also having your lesson plan up so that you know when you need to pop in with extra information. We were just looking at the preview, but when you're ready for your students to complete this lesson, what you'll do is click Assign. From here, you'll notice that you can only assign lessons to classes that belong to you inside of SAM Studio. If you are using Clever and ClassLink, your classes that are synced to you should already be showing up inside of SAM Studio. If your students are rostered manually, then the students that you've rostered manually will show up here as well. Let's say I want to assign this to my class and computer science. I can click Edit to change the due date. Maybe we're working on this on Friday, and then Submit. Now, when my students log in and go to their interactive lessons, they'll see that they have an assignment to complete. From here, you can no longer edit the assignment after. You can see that the edit button has kind of whited out. You can no longer edit the classroom once you've, you can no longer edit the lesson once you've assigned it, but you can remove an assignment. Then you'll be able to edit it again. But after it's been assigned, you can no longer edit. You can, though, edit the due date, and it's important to note that students can still complete work after the due date. I'm going to pull up a lesson that I've assigned so you can see what it looks like once students have turned in their work. Let's look at this one here. Nope, wrong one. Sorry, I have too many interactive lessons. So once students have turned in their work, you will be able to see their submissions. Thank you for bearing with me as I find one that works, or one that I've already graded, sorry. That's okay. So when your students turn in their work, you'll see their assignments listed here. And you'll be able to go in and give them grades and give them feedback. Here we go. I was clicking the wrong button. In this case, you can see that I have 2 students that have submitted it and 1 student whose work is past due. If this has already been graded, it will show me the option to update the grade and it will give me the total score. And if I want to click Update Grade here and review this student's answers, I can come in here and view their answers. Again, this matching activity auto-graded, but this code did not auto-grade. I had to come in here. I had to look at my teacher lesson plan and see if they completed this correctly, and then I can give them feedback. You'll also have a default rubric that's available so that you can see what necessitates a 4 versus a 3, 2, 1, 0. Some lessons will have your students upload pictures of prototypes or upload screenshots of codes. Others will have them answering reflection questions. Here you can see it was a close activity. They missed one. At the end of every lesson, we ask students to evaluate themselves on how they used a future-ready skill. In this case, the student said, I gave myself a 4 out of 4. They were able to connect the scientific knowledge they learned to real-life applications. And they gave themselves that rating because they did a great job. You as the teacher then can respond to what your students answered and save the grade that you gave them. We just walked through how to assign and grade interactive lessons. If you have any questions about that process, please feel free to come off of mute or to write those questions in the chat. Know that the slide deck that will be shared with this training has different pages on saving and editing interactive lessons and how to complete that with your students. For another resource that I highly suggest saving, if you go into the Content Hub and scroll down a few rows under Getting Started as a Teacher, there's this resource here called the Tutorial and Resource Hub. The Tutorial and Resource Hub has videos for how to assign interactive lessons. If we scroll down here at the bottom, there's one video on finding, adding, and assigning interactive lessons, and another on completing and grading those interactive lessons. And that's a great place to look for a review. Again, I found that under our SAM Labs Resource Hub, which I suggest bookmarking. And you can find that at the Content Hub by searching either tutorial, that would find it for you, or by going to the homepage and just scrolling down a few rows until you see it here under the Getting Started as a Teacher resource. We've already started talking about some of the hardware that your students will use during the middle school STEAM course. They won't use every single piece of SAM Labs hardware every day, but they will use different blocks as they go throughout the course. And again, the recommended hardware is a STEAM Classroom kit and a STEAM Plus kit. Just as a quick refresher, those SAM Labs blocks need to be charged. They each have their own internal battery, with the exception of the microbit that works a little bit differently. You, in your kits, will have these little white squid chargers that can charge up to 5 blocks at a time. Or you may also have a separate charging station that can charge up to 40 blocks at a time. And that looks like what's pictured in the bottom right-hand corner here. The very first time you get your kits, remember to charge them for a few hours to make sure they get fully charged. When you plug them into the charging station and the charging station is plugged into the wall, the blocks will light up red as they are charging. And when they are fully charged, they will turn green. Once they're charged, blocks should last 8 hours. That means they could be powered on for 8 hours and running, and they wouldn't die until the end of the day. You're likely not going to need to charge the blocks every single day because your students will be using them for maybe 20 minutes at a time max, and they'll be turning them on and off throughout the day. Between charges then, they just take about 45 minutes to get fully charged. And we always recommend that adults are the ones plugging in and unplugging the blocks, or that you explicitly teach your students that routine and maybe have a classroom job of somebody whose job it is to plug in and unplug the blocks, just because the charging ports can be a bit fragile. There is a GIF here on the next page about the best way to plug in the blocks. We find that rolling them onto the charging station works better than trying to put them down at a straight 90-degree angle. And you can see that pictured here in this GIF, right? We're rolling it on. If you have questions about charging your blocks, reach out to your customer success manager, or you can reach out to our support specialist. Most schools that have SAM Labs access have hardware warranties, or will replace broken or faulty blocks. And that replacement request is linked on this slide as well. I've mentioned that in this course, students will use 2 different coding platforms, both SAM Space and SAM Blockly. So I wanted to give us a bit of a refresher about how those coding platforms work. We start all students out at SAM Labs, whether they are in kindergarten or 8th grade, in what we call SAM Space. SAM Space is a coding platform that's pretty unique to SAM Labs. It uses what we call flow-based coding. In flow-based code, students are building a system of interdependent devices that are made up of inputs and outputs, and they process data. We use flow-based coding in our platform, SAM Space. So I'm going to go over here to my homepage under my projects. And I'm going to click and create a new SAM Space project. To create a project in SAM Space, you can either click Create New in your top right corner and select SAM Space, or you can just select SAM Space from the Create menu on the left-hand column of your screen. When we open SAM Space, you'll see that flow-based platform here. SAM Space is very visual. It doesn't require any background knowledge about coding or the vocabulary that goes along with it. It's designed to be an entry point for students of all ages and ability levels. When we use SAM Space, you'll notice that there are blocks at the bottom of the screen that look a lot like are blocks that we make here at Sam Labs. I've got a physical block in my hand, but there are virtual blocks here on the screen, and they're sorted into 3 different categories: inputs, outputs, and behaviors. We teach students how to use this platform in our starter unit, Welcome to Sam Studio. But for our intents and purposes today, as a little bit of a review, in Sam Labs and in coding, an input is something that's going to bring information into our system. In Sam Studio, you'll see your inputs here. It's kind of like the start button or the cause of a cause and effect statement. Some inputs that students will have access to, either virtually or physically, are a key press, a button, a light sensor. They'll have different kinds of sensors like pressure sensors and proximity sensors, and other types of blocks as well. These are all set to bring information into our system. On the flip side, we have our outputs. Inputs are bringing information in, outputs give off information. We can think of inputs and outputs like an if-then statement. If I have this input, then I have this output. If I flip my switch, then the light will come on. If I pull the string, my fan will start spinning. So that if-then causality, or that logic, is what we're building with inputs and outputs. Take this as an example. As an input, I'm going to grab my virtual key press button. A key press can be any key on your keyboard, and you can change it, but right now it's defaulted to be a space bar, but you can change it to another key by clicking your block that you've dragged onto your workspace and clicking the settings wheel. It can be any letter on your keyboard or the space key. Side note, if your students are working on an iPad and don't have a keyboard, they can press this little play button at the top instead of pressing the actual space bar. But I have a keyboard, so I'm going to press my space bar. You see that it's kind of graying out this block here as I hold down my space bar, but nothing else is happening. That's because right now I only have an input. I don't have any output. I've got the logic if I press the space bar, but I'm not telling it what to happen next. So what I can do here is click outputs and add an output. Every system will need at least one input and at least one output. Maybe my logic here is that I want a light to turn on when I press my space bar. So my light is called an RGB LED. If you have kids that want to know what acronyms stand for, it is a red, green, blue light emitting diode. If you're like me and you're more of a kindergarten level, it is a rainbow light. It's a light that can light up lots of different colors. So you can see I have my input towards the left-hand side and my output on the right. That organization is important. We want kids to recognize that coding is like reading, writing. It happens from left to right and top to bottom. I can go ahead and press my space bar again, but my RGB LED, my light, is still not lighting up. That's because right now I have 2 systems. They're not connected. And it's kind of hard to see, but if I click my space bar here, you can see there's blue around it. And if I click my RGB LED, you can see that this is green. These are a part of 2 separate systems. To make them work together, I need to connect them. So I take this little blue dot, drag it towards my green dot, and now you can see that it changed my RGB LED to blue. These are both a part of the blue system. And now when I press my space bar, my light lights up. So my logic here is this. When I press the space bar, it turns on my RGB LED. When I let go, my LED turns off. This is very simple logic that students start to understand that cause and effect relationship between inputs and outputs. We can also add different behaviors in that modify our code. So behaviors are used to help us build out logical sequences and loops and intervals that tell the input and output how to communicate. Right now, I just have that simple logic. When I press my space bar, my light turns on. But maybe I want to make this work more like a real light. In your classroom, a student doesn't have to stand in the corner all day holding the light switch on. They just have to flip it once, and then the light stays on until they flip the switch again. We can simulate that with a behavior. So if I go under behaviors, I can see that there are different folders. Each folder has different behaviors underneath it. If I wanted to find a behavior that had to do with math, I would click numbers. If I wanted to change the color, I would click colors. In this case, though, I want it to act like a switch, so I'm going to use switches. And here, kids will do some trial and error of figuring out what works the best. But they'll eventually figure out that if they pull a toggle block and drop it right on top of their connecting line, it's now in the middle of this logic. Now, if I press my space bar, my logic sounds like this. If I press my space bar, it will toggle on my light. If I press my space bar again, my light toggles off. So it's kind of creating a hold here, right? It's keeping my light on, even though I'm not holding down my space bar. Students will start with really simple systems like this, but then move into some pretty complex systems. If you're new to Same Space, also know that up here is where you can name your project. We recommend having students name their project something easily referenceable, like the name of the lesson, so that they can go back and edit it another day. There are also extra settings on the right-hand side where students can change their language and view a few other settings. If they turn off a setting like group behaviors, it will affect what they can see. For example, that group behavior setting was what put all of my behaviors into boxes or into categories. I turned off group behaviors. Instead of seeing categories now, I just see a long list of blocks. For me, that makes it visually overwhelming, so I like to keep that group behaviors turned on. Same goes with virtual blocks. If I turn off show virtual blocks, it doesn't show me any of my Sam Labs blocks anymore, and I won't see the Sam Labs blocks until I connect one to Bluetooth. To illustrate that, once I turn on my RGB LED light and connect it to Bluetooth, now I will see it as an option on my screen to code this. If you're curious about how to pair blocks, this is not a block pairing workshop, but we are hosting block pairing workshops and introductory workshops that will walk you through doing this process with your students. Now you can see my RGB LED is connected. It's lighting up blue, just like my system on the screen is blue. I press my space bar, my actual light lights up. Press it again, turns off. And you can see I've also got a light sensor down here. I haven't done anything with my light sensor, but because I've connected it to Bluetooth, I can see it at the bottom of my screen. If I turn that setting show virtual blocks on, now it shows me all of my blocks, whether they're virtual or physical. The last setting, K1 Simple Workspace, is not designed to be used in middle school. It's designed for kindergarten and first graders. It limits the amount of blocks that they see on the bottom to only what's in their Sam Labs classroom kit. You'll want to make sure that students by default have the K1 Simple Workspace turned off, show virtual blocks turned on, and group behaviors turned on. The settings here are going to be specific to their own computer. Like students have to change the settings on their own devices, but once they change the settings, their computer will default to that until it resets. That was a very quick overview of Sam Space. But now I want to show you the same kind of overview in Sam Script, which is the second coding platform that they use. On the left-hand side of the screen, you see Sam Script right here. We'll click Sam Script. And I'm going to show you a similar lighting system, but this time in our Sam Script platform. Sam Script is not just script-based coding, it's hybrid block and script. Students are able to start coding in a block-based code and then translate their code over into JavaScript and into Python. This allows students to up-level and to differentiate because you may have students who are ready to start coding from scratch in Python. You may have students that aren't ready for that yet and are more comfortable staying in blocks. And maybe you have students who are transitioning to learning more about JavaScript. Then they can come in here and start analyzing the JavaScript code and figuring out how to change it. This system here is a lighting system, but it differs from the last system I showed you in Sam Space because here, as my input, I'm using a light sensor. And my logic here says when my light sensor senses a value of less than 25, then it's going to turn on my RGB LED light. And it will be at a brightness of 70, the color of the light will be blue. The power of this is that students in JavaScript can be challenged. what if you wanted your light to light up yellow instead of blue? Where do you think that you would change that here? By quickly scanning this code, students will probably notice the word blue is right here. Maybe they'll say, what would happen if I change that to yellow? Now, if I run my virtual code again, it hasn't changed to yellow yet. Sometimes we need to refresh it or go back into blocks to make that change stick. And sometimes it just doesn't work as expected and we need to try again. But I can also go to blocks and fix that as well. So instead of yellow, maybe I'll change this to green or to white. And then you can see my light would change. We can also connect to our blocks in this platform. We just turn them on, pair by clicking connect. And we pair to our blocks this way. One helpful thing to note is that the scope and sequence often has codes for students to input. That means they're not necessarily required to start from scratch. For example, you can see right here in lesson 4 from the first unit, there is a timed crosswalk and a timed traffic light. You don't have to figure out how to build that from scratch. Before the lesson, you can click that lesson or click that link and download a code. This code is in Samspace, so you can see I've got a download now at the top of my screen. And what I do is I go back into Sam Studio under my projects, and I'm going to click the word upload. It's hiding behind that download here. But I'm going to click the word upload here and drag and drop that code. Now when I click import, it imported my traffic light project. I didn't need to do it from scratch. You don't need to do it from scratch. You can use this as an example to show your students. There will even be some lessons, especially later in the course, that it asks students to download and import a code as a starting point. For example, down here in the AI unit, Artificial Intelligence Unit 9, there's a pretty complicated AI system in here. We can download that code again, go back into Sam's script and click import. When I drag and drop that code here, it will load the project and add it right in. Here, it's a 20 questions game, and hard to see because it's really zoomed in. But it runs a 20 question game. Does your animal live in the jungle? Let me think of an animal. Yes, it does. Is your animal a cat? No. So it's showing students how to build the system. Is it a gorilla? No. So it goes through a 20 questions game that students can continue to build out. You can see this only had a couple of steps and it needs to be completed by your students. As they work through the course, students will get more comfortable using Samspace and Samscript. And they'll go back and forth between using both. If you're curious, Unit 1 introduces both Samspace and Samscript. Units 2, 3, 4, and I believe 5 all only use Samspace. And then when you jump into Unit 6 and beyond, they start using Samscript. So you may decide, and the course is designed so that students start off in Samspace lessons, so that once they get expertise there and they learn the language of the code and the logic behind it, then they can start jumping into Samscript later in the course. Or maybe you teach 2 different grade levels and you have 1 grade level that works on the Samspace lessons, while the next grade level works on the Samscript lessons. Your customer success manager is here to help you and decide what to teach when and how to show your students. There's some extra information in these slides for you on how to use that. But I wanted to quickly, before we wrap up, share some best practices. As I mentioned earlier, during the lesson, I highly recommend projecting the student view of the interactive lesson as you work through with your students. There is not an individual slide deck for every lesson like we have in our K-5 courses. However, for each lesson, you do have a generic timing slide deck that you can make a copy of here in Google Slides and edit these to fit your lesson if you're the kind of teacher that likes having the structure of a slide deck. So you're able to copy these and edit them for your lessons and add any videos, questions, and information in that you want to be sure to share. I also recommend to pay attention to those lesson plans. The interactive lessons are not designed to be 100% independent. They are designed to have teachers facilitating. So be sure to know where you as the teacher need to step in and share that information with your students. And then last but not least, I recommend labeling your blocks with their pairing IDs, and that link will help you here. I also recommend heading to that pairing ID workshop to teach you how to go through that process in more detail. There are also a few anchor charts that are shared here that are clickable and downloadable that you can share with your students for how to pair their blocks in SamSpace and in SamScript. And a bit of a background information, I'm using 2 blocks that will be new to the middle school course, which are a microbit and a servo motor. They both require some setup steps, and there are links for the setup steps on each page here. Before we wrap up today, and before I share a bit of extra information with the folks that are on this call, are there any questions that you want to ask? Feel free to come off of mute or to type in the chat. Or you can also reach out to me for your customer success representative's email address, and I can have them answer any questions for you too. Thanks, Robin. What I'm going to do is pause my recording. So thanks to the folks who are watching this recording and were able to attend live, but we'll go ahead and